This video is on applications of derivatives and maxima minima problems based on it. To solve problems, we first form an equation, reduce it to one variable, find the first order derivative, equate the first order derivative to 0 and get the critical points. Find the second order derivative, and if it is greater than 0, there is a local minima. If it is less than 0, there is a local maxima. Coming to the first problem, the sum of the surface areas of a rectangular parallelepiped with sides x, 2x and x by 3 and a sphere is given to be constant. Prove that the sum of their volumes is minimum if x is equal to 3 times the radius of the sphere. Also find the minimum sum of their volumes. Surface area of a cuboid is length into breadth, twice length into breadth plus breadth into height plus length into height. That will be 2x into 2x plus 2x into x by 3, which is 2x squared by 3, plus x into x by 3, which is x squared by 3. Simplifying, you get 6x squared. Surface area of a sphere is 4 pi r squared, assuming the radius is r. So total surface area, since we have the sum of the surface area of a cuboid and a sphere, the total surface area is given by 6x squared plus 4 pi r squared. We have two variables here, x and r, so we can either differentiate with respect to x or with respect to r. Differentiating with respect to x, s is a constant, so we get 0 equal to 12x plus 8 pi r dr by dx. So taking one term to the other side, we get 12x is minus 8 pi r dr by dx, or dr by dx is minus 3x by 2 pi r. Now going back to the problem, we need to find the minimum volume. So volume for a cuboid is 4 by 3, for a sphere is 4 by 3 pi r cubed. For a cuboid, it is length into breadth into height. That would be x into 2x into x by 3. So it would be 4 by 3 pi r cubed plus 2x cubed by 3. Differentiating with respect to x, we get dv by dx is 4 by 3 pi into 3r squared dr by dx, because we are differentiating with respect to x, plus 2 by 3 into 3x squared. So this is the 3 and 3 gets cancelled, you get 4 pi r squared, dr by dx is minus 3x by 2 pi r. Again the 3 and 3 gets cancelled, you get plus 2x squared. So dv by dx squared, when you simplify this, you get minus 6xr plus 2x squared. Equating dv by dx to 0, you get 6xr is 2x squared or x is 3r. Now this is your dv by dx. Calculating d2v by dx squared, this would be minus 6. Apply the product rule here. So you get x into dr by dx plus r. That is x dr into dr by dx plus r into dx by dx is 1. So plus 4x. Opening the bracket, you get minus 6r minus 6x. Now we have already calculated the value of dr by dx is minus 3x by 2 pi r plus 4x. That is minus 6r plus 9x squared by pi r when you simplify this plus 4x. At x equal to 3r, d2v by dx squared would be minus 6r plus 9 into 3r the whole squared by pi r plus 4 into 3r. Simplifying, you get 6r plus 81 r squared by pi r. This would be greater than 0 since r cannot be negative. So d2v by dx squared at x equal to 3r is greater than 0. So by the second derivative test, volume is minimum when x equal to 3r. And the minimum volume will be, put x equal to 3r in your formula for volume. So I get 4 by 3 pi r cubed plus 2 by 3. Instead of x cubed, I will put 27 r cubed. That would be 4 by 3 pi r cubed plus 18 r cubed. Next, find the dimensions of a rectangle of perimeter 36 centimeters, which will sweep out a volume as large as possible when revolved about one of its sides. If this is a rectangle with length y and breadth x, 2x plus 2y is 36 because the perimeter is 36. So y is 18 minus x. When you sweep a rectangle, say about the length, we get a cylinder of height y centimeters and radius x centimeters. Now volume is pi x squared into y. Converting it to one variable, you get pi x squared into 18 minus x. that is 18 pi x squared minus pi x cubed. So dv by dx would be 18 pi into 2x minus 3x squared into pi. Equating it to 0, we can take out 3 pi x, so you get into 12 minus x equal to 0. So x equal to 12. Again, d2v by dx squared would be 18 pi into 2, that is 36 pi minus 6x pi. And d2v by dx squared at x equal to 12 would be 36 pi minus 72 pi, which is less than 0. So again, by second derivative test, volume is maximum when x equal to 12 centimeters. Next, a rectangle is inscribed in a semicircle of radius r with one of its sides on the diameter of the semicircle. Find the dimensions of the rectangle so that the area is maximum. Also find the maximum area. If this is a rectangle and this is the diameter of the semicircle, from the center of the rectangle we form a right angle triangle. So if angle OAB is theta, cos theta is adjacent side by hypotenuse, which is OB by R. So OB is R cos theta. Sin theta is AB by R. So AB would be R sin theta. So the breadth of the rectangle is R cos theta and the length would be 2R sin theta. So area would be 2r squared cos theta sin theta. Now 2 sin theta cos theta is sin 2 theta, so it is r squared sin 2 theta. So dA by d theta, calculating the first order derivative, it would be r squared cos theta cos 2 theta into derivative of 2 theta, which is 2. Equating dA by d theta to 0, we get cos 2 theta is 0. That means 2 theta is pi by 2, so theta is pi by 4. And d2a by d theta squared will give you r2r squared. Derivative of cos 2 theta is minus sin 2 theta into 2. So we get minus 4r squared sin 2 theta. And d2a by d theta squared at theta equal to pi by 4 would give you minus 4r squared. Sin pi by 2 is 1. So I get minus 4r squared, which is less than 0. So again, by second derivative test, area is maximum when theta is pi by 4. And the maximum area is given by r squared.